So in this skill sheet, we focus on unit conversions. And we said that unit conversions were really about converting units, which is kind of as the name implies. And we call this process dimensional analysis. And then we said what you're going to do is write down a given unit first, write down a desired unit second, and then use these conversion factors to cancel units to get from the given to the desired. So let's go through a few of those practice problems again. So in this first one, we have 256 nanometers as our given. I would go ahead and write that down on the left side of the screen. And we're looking for centimeters here on the right. So for this type of problem, I would just think about my metric units. And for every 1 meter, I have 1 times 10 to the 9th nanometers. The reason I put the nanometers unit on the bottom was so it could cancel out. I'm now left over with the meters unit on top, which is not what I was looking for. That's how I know I need to keep going with my conversion factors. Now I remember some more metric conversions, that 1 meter is equal to 100 centimeters. I put the meters unit on the bottom so it would cancel. I'm left with centimeters on top, which is what I was looking for. That's how I know I'm done with my setup. I can now get out my calculator, type in 256, multiply by 100, enter, and then divide it by 1 times 10 to the 9th. You could also take 256 and divide it by 1 times 10 to the 9th first, and then multiply by 100. When multiplying and dividing, the order of operation isn't going to matter here. So we end up getting 2.56 times 10 to the negative 5th centimeters. And that would be our final answer. Let's jump to C here. So this problem is asking for how many kilograms are in 125.0 pounds. So let's write down what we're given. So we're given pounds, and it's asking us to convert that into kilograms. So for this problem, I don't expect you to memorize any of the non-metric prefixes or units. So you're going to get a list kind of like this that shows you all the useful conversion factors. Now looking at this list, it looks like it's got some information about pounds and ounces, pounds to grams, grams to kilograms, but it's also got this one right here that lists a direct link between kilograms and pounds. So that's the conversion factor I'm going to use. So before I put the numbers in, I'm going to make sure that I get my pounds unit on bottom because that's the unit I'm trying to cancel. And we're looking for kilograms, so let's get that on top. And then when we look at the conversion factors, we know that there are 2.2 pounds per 1 kilogram. So my pounds unit cancels. We're left with kilograms. That's what we were looking for, so we're done with setup. Now we can get out the calculator and do 125 divided by 2.2. Now when you're trying to think about how many numbers to put in this final answer, how many sig figs should go here, I want you to always look at the beginning information. Forget about the conversion factors. They have no influence on this. Since there are 4 significant figures in 125.0, we're going to try and get 4 significant figures in this answer. So 56.82 kilograms would be the perfect answer. Okay, let's try D now. How many milliliters are in 2.0 gallons? So let's write down our starting information with the starting unit on the left, and let's try and write down our desired unit on the right. Okay, now looking at our list, it doesn't look like there's a direct link between gallons and milliliters. In this case, I'm going to kind of want to look at my gallons and liters, and then I can maybe use my metric conversion using milliliters and liters. So I'm going to start out. I'm going to make sure my gallons unit goes on bottom, and my liters unit goes on top, and that 1 liter was equal to 3.785 gallons. And again, why did I put the gallons unit on bottom? Go ahead and say it out loud. Why did I do it? I hope you're thinking about that cancel word right now. So we're canceling these units. Okay, then we remember that 1 liter is equal to 1,000 milliliters. We put the liters unit on the bottom so it cancels. Our unit matches our destination here, so we're done with the setup. And then on our calculator, we can do 2.0 times 1,000 and then divide it by 3.785. Now this problem, we get maybe a longer answer, but if we look at our starting information, 2.0 is 2 sig figs. So I'm going to round my final answer to 7,600 milliliters. So I also have 2 significant figures in my answer. Okay, the last problem. What do we do when we have units on top and bottom? If we're trying to use 100.0 meters per 9.58 seconds and turn that into miles per hour. This is actually the time it took Usain Bolt to run his 100 meters in the Olympics, the fastest a human has run. Just because there are numbers on the top and bottom and units on the top and bottom, we're not going to let that change our strategy. Let's write down what we know on the left and what we're looking for on the right. Now, really, it's your choice to decide here. Do you want to turn meters into miles first or seconds into hours? Either way, I would go with one long pathway here. I'm going to go ahead and get rid of my seconds first and turn it into hours. I know that there are 60 seconds in 1 minute, and there are 60 minutes in 1 hour. Now, I put the seconds on top so it would cancel with the seconds on bottom. And then I put the minutes on top so it would cancel with the minutes on bottom. I'm now left with hours on the bottom. Perfect, that's what I was looking for. If I were to stop now, I would be calculating meters per hour, which is still really something I have a hard time thinking about. Now, my meters unit is over here on the far left. No matter what, I need to get a meters down here to get it to cancel. Now, I remember that there were 1,000 meters in 1 kilometer, so I'm going to go ahead and start with that one. My meters unit's gone now. How many kilometers are there in a mile? I don't expect you to memorize that one, so that would probably be on this list. Let's look. There we go. 1 mile is 1.609 kilometers. Since the kilometers unit is on top here, let's make sure the 1.609 goes on bottom and the 1 mile goes on top. If you look now, we have miles left over on top, we have hours left over on bottom. Perfect, that's what we were looking for. So I would on my calculator now go 100 divided by 9.58, don't forget about this one, times 60, divided by 1,000, divided by 1.609. And if you look at the beginning, we have 4 sig figs in 100.0 and 3 sig figs in 9.58. So I think we want the fewest in the problem in our final answer. So I would say 23.4 miles per hour is how fast Usain Bolt is running.